Welcome back. We know a rock's porosity measures its storage space. But what fills that space? Today, we explore fluid saturation. In a reservoir, the pore volume is never empty. It is always occupied by a combination of fluids, hydrocarbons, oil or gas, and water. Fluid saturation, S, is the fraction of the pore volume, V pore, that is occupied by a specific fluid, V fluid. It's the measure of how full the pores are with a particular fluid. Crucially, in a two-phase system, hydrocarbon and water, the saturations add up. Saturation of oil plus saturation of gas plus saturation of water equals 1. We focus on three main saturations: water saturation, hydrocarbon saturation, and a special case, irreducible water saturation. Water saturation, S sub W, is the fraction of pore volume occupied by formation water. Since water is typically the wetting phase, it naturally clings to the rock grains. Hydrocarbon saturation, SHC, is the fraction of pore volume occupied by the valuable fluid, oil, SO, or gas, SG. This is the volume we are interested in producing. For reserve calculations, if we can accurately determine SW, we automatically know SHC, which is the primary variable for estimating stock tank oil initially in place, STOIIP, or gas initially in place, GIIP. This leads us to a crucial concept: irreducible water saturation, SWI. Even in a productive oil or gas reservoir, water is always present. SWI is the minimum water saturation that exists when the reservoir is at its maximum hydrocarbon accumulation. This water is held in place by capillary forces and is immobile. It will not flow when the well produces. SWI is indirectly related to pore size. In rocks with very small, tight pores, capillary forces are high, leading to high SWI. In rocks with large, well-sorted pores, SWI is lower. In the reservoir zone we want to exploit, the measured water saturation SW should ideally be equal to SWI. If SW greater than SWI, that extra mobile water will be produced with the hydrocarbons. How do we find S sub W in the Earth? Since SW determines SHC, accurately measuring SW is paramount. The primary method is well logging, specifically using resistivity logs. Formation water contains dissolved salts, making it electrically conductive and low resistivity. Hydrocarbons are non-conductive and have high resistivity. Archie's equation links the measured formation resistivity, RTD, to the water saturation. In short, high resistivity equals low saturation of water equals high saturation of hydrocarbons equals good reservoir. Fluid saturations are the final piece of the puzzle for calculating original hydrocarbons in place. Together with area, height, and porosity, saturation determines the total volume of oil or gas trapped in the reservoir. Recap: fluid saturations quantify the amount of valuable hydrocarbon versus non-valuable water in the pore space. Saturation of water is measured using resistivity logs and is critical for reserve estimation. Now that we know how much fluid is stored, we need to know if we can get it out. Join us next as we explore the dynamic property of permeability, the rock's ability to flow fluids. Thank you for watching. Do like. Also subscribe and send this informative video to your friends.